Hello students, today we solve one question based on combination of lenses. The question is two convex lenses A and B, each of focal length 10 cm are mounted on an optical bench at 50 cm and 70 cm respectively. Object is mounted at 20 cm. Find the nature and position of the final image formed by this combination. Let's see question in detail. There are two convex lenses of focal length 10 cm. One lens is placed at 50 cm on the optical bench and another one is placed at 70 cm. So the distance between the two lenses is 20 cm. We mark one lens as lens 1 and another one as lens 2. Object is mounted at 20 cm on the optical bench. So the distance between the object and the lens 1 is 30 cm. We need to find the nature and position of the final image formed by this combination. First we find the image formed by the lens 1. We have focal length of the lens 1, that is 10 cm, and the object distance is 30 cm. According to the sign convention, it is minus 30 cm because we measure object distance opposite to the direction of the incident ray. This is the direction of the incident ray. We measure object distance in this direction, so it is minus 30 cm. Now we substitute all the values in the lens formula and we write lens formula for the lens 1 as 1 by V1 minus 1 by U1 equal to 1 by F1. We substitute all the values and we get 1 by V1 equal to 1 by 15. So the image distance for the lens 1 is 15 cm. That is, the image is formed at 15 cm from the lens 1 somewhere here. Now this image is acting as a virtual object for the lens 2. So what is the object distance for the lens 2? That is, from the lens to the image, this virtual object is 5 cm. According to the sign convention, it is minus 5 cm because it is opposite to the direction of the incident ray. So it is minus 5 cm. And we know focal length, that is 10 cm. And we substitute all the values in the lens formula, we get the position of the final image. We write the lens formula for the lens 2 as 1 by V2 minus 1 by U2 equal to 1 by F2, and we substitute all the values, we solve, we get the image distance for the lens 2 as minus 10 cm. So the final image is formed at minus 10 cm from the lens 2. Here the object and the image is on the same side, so the final image is erect and virtual image.